Hi students, this is Alex here. In this video they have given an insulated rod of length L has its ends A and B kept at A degree centigrade and B degree centigrade until steady state condition prevail. So we take a small diagram for the reference. We have a rod of length L and one end is A and other end is B and this length is L and this is kept at A degree centigrade and this end is kept at B degree centigrade until steady state condition prevail. Then the temperature at each end suddenly reduced to 0 and kept so, and we have to find the resulting temperature at any point of the rod taking the end A as the origin. Now let's take the heat equation. The heat equation is dou U by dou T equal to alpha square dou square U by dou X square. Now we have a steady state. So there is a steady state condition. Therefore dou U by dou T will be 0. Change in temperature with respect to time is 0. Using that here, we get dou square U by dou X square will be 0. On integrating this, we get a constant. That integration is AX and plus another constant. So therefore, we get a solution U of X as AX plus B by integration solving this. Now at X equal to 0 is the end A. We have the temperature U as A degree centigrade. So using that here, so A degree centigrade will be A into 0 plus B. So we get the constant B as A degree centigrade. Similarly, at X equal to the length L, that is at the end B, and the temperature U is B degree centigrade. So B equal to, here I am using B, and A is a constant which keep as it is, X is L and B we just now got as A degree and this is B degree. So from this I can find the value of A. I can take this to the other side. So B degree minus A degree by A is our L. Sorry, by L is our A. So we got the constants A and B. So A is this and B is this. We have to replace both in this to get U of X. So U of X is AX. So U of X is AX. So A is B degree minus A degree by L. So now instead of B degree I use B minus A by L itself because B degree is B into X plus B which is A. So I got the U of X. Now I am going to write the boundary condition. Then after the steady state, suddenly both the ends are reduced to 0. So let's write the boundary condition. First is U of 0 comma T is 0 because at X is 0, the temperature is 0 for all T greater than or equal to 0. In the same way, the other end U of L comma T is also 0 for all T greater than or equal to 0. And the third condition is U of X comma 0 will be B minus A by L into X plus A, and this we have it as a third condition. Now we are going to write the suitable solution for the heat equation. So the suitable solution is U of X comma T is A cos Px plus B sin Px into e power minus alpha square p square t. Now let's use the first condition. Using the first condition, which is U of 0 comma t is 0. So wherever x is there, I have to put 0. So when I put 0 in these places, I am going to get U of 0 comma t is a into cos 0 is 1 and sin 0 is 0. So we have only a e power minus alpha square p square t, and this value is 0. So 0 equal to a e power minus alpha square p square t, and from this e power minus alpha square p square t definitely cannot be 0. Therefore, the only possibility is A must be 0. So we got A as 0. Using that in our solution, u of x comma t becomes A is 0 here. So we have only B sin px into e power minus alpha square p square t. Now in this we are going to use the second condition. So using the second condition, u of L comma t is 0. So wherever x is there, I have to substitute L in these places. So this will become u of L comma t equal to B sin PL into e power minus alpha square p square t. Now this is 0. So 0 equal to B sin PL e power minus alpha square p square t. Now from this we cannot take B as 0 since already A was 0. So again the another constant cannot be 0. Again e power minus alpha square p square t also not possible to be 0. Therefore the only option left is sin PL must be 0. Whenever we have sin theta equal to 0, its solution theta is n pi. So PL equal to n pi, and from this P is n pi by L. So we are going to use that in our solution. Going to replace P. So u of x comma t becomes B sin Px, P is n pi by Lx into e power minus alpha square, P square is n square pi square by L square into t. Now we can take this as u of x comma t equal to summation from n is 1 to infinity. We have the constant b is written as bn sin n pi x by L e power minus alpha square n square pi square by L square into t. We are going to use the third condition. So using the third condition is u of x comma 0 is b minus a by L into x plus plus a. So let's check it here. B minus a by L x plus a. So we are going to use that. So wherever t is there, we have to substitute 0 in these places. So when t is 0, this is u of x comma 0. Now summation n is from 1 to infinity bn sin n pi x by L, and e power 0 is 1. And now u of x comma 0 is our function b minus a by L into x plus a. This is equal to summation n is from 1 to infinity bn sin n pi x by L. Now this is the half range Fourier sine series. This is half range Fourier sine series, and here to find Bn we use 2 by L integral 0 to L f of x into sin n pi x by L dx. This is our f of x. We are going to substitute here. So 2 by L integral 0 to L b minus a by L into x plus b, the whole thing into sin n pi x by L dx. And sorry, this is not b, this is a. Now to continue this integration, we are going to use Bernoulli's formula. This is u and this is b. So u equal to b minus a by L x plus a, and v is sin n pi x by L, and u dash will be, its differentiation is b minus a by L alone, because x differentiation is 1 and this constant a differentiation is 0, and u double dash will be b minus a by L is fully constant, so it is 0. From v we have to integrate to get v1, which is minus cos n pi x by L by n pi by L, and v2 is minus sin n pi x by L by n pi by L whole square. Now the Bernoulli's formula is u v1 minus u dash v2 plus u double dash v3 dot dot dot. So we have Bn, we had 2 by L outside, u is b minus a by L x plus a, the whole thing into v1, which is minus cos n pi x by L by n pi by L, minus u dash, which is b minus a by L into v2, which is minus sin n pi x by L by n pi by L whole square. Then we have to apply the limit from 0 to L. When we substitute the upper limit for x, so here, here and here, everything will become L. So Bn will be 2 by L. This, after putting L here, LL gets cancelled. We have b minus a, then plus a. Then when I put L here, we get cos n pi. There is a minus 1. Cos n pi is minus 1 whole power n by n pi by L. And here when I put L, sin n pi is 0. So totally the term is 0. Minus, when I substitute the lower limit, which is 0, and when I put 0 here, this term is 0, only a will be remaining. So I keep a here, and there is a minus 1, there is a minus sign, and cos 0 is 1. So minus 1 by n pi by L. When I put 0 here, sin 0 is 0. So totally it is 0. So we have only this much. And the common denominator we can take out, plus a minus a we can cancel. So 2 by L, we can take n pi by L, that L I can carry the numerator. So this is b, there is a minus sign. So minus b, then minus 1 whole power n. And this we can cancel and make it as plus. So after cancelling this, we can just rearrange the term. Finally, Bn is 2 by n pi, and let's write the first positive term a, then minus b times of minus 1 whole power n. This is the value of Bn, and we have to substitute this in our solution. So u of x comma t, we had summation n is from 1 to infinity, Bn, which is 2 by n pi a minus b minus 1 whole power n. Then we have sin n pi x by L e power minus alpha square n square pi square by L square into t. And the constants can be taken outside the summation. So u of x comma t will be 2 by pi. Then summation n is equal to 1 to infinity, and we have 1 by n. Then we have a minus b, then minus 1 whole power n, then sin n pi x by L e power minus alpha square n square pi square by L square into t. This is the required solution for the given problem.